Hello, and welcome to today's chemistry class for S.S.1. In today's class, we will be talking about relative atomic mass. But before we proceed, let's talk about the lesson objectives. At the end of the lesson, the students should be able to define relative atomic mass, explain why relative atomic masses are not whole numbers, explain isotopes. The relative atomic mass of an element is the number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon-12. Don't forget that carbon has two isotopes, carbon-12 and carbon-13. But we are using carbon-12 arbitrarily. In the science world, that is how it was selected. So if you take carbon-12 and you divide it into 12 places, its mass, the mass of one part of it, the relative atomic mass of any other element, is calculated based on that mass of 1/12 of that carbon-12. And so, the relative atomic mass, of course, it has a symbol AR, is a dimensionless physical quantity. What this means is you can easily write the value without even putting a unit. Now, the mass spectrometer is the gadget, is the machine that is used to measure relative atomic masses of elements. And then, relative atomic masses of elements are not whole numbers. This is due to the existence of isotopes. Most elements have isotopes. And remember, we have said that isotopes are elements that have the same atomic number but different mass numbers. That difference in the mass number is caused by the difference in the number of neutrons in the nucleus of the atoms. So, talking about isotopes, like we said in the earlier slide, they are elements with different mass numbers but the same atomic numbers. Here we are going to use the nuclide of hydrogen as an example. You can see there we have hydrogen 1, we have hydrogen 2, and then we have hydrogen 3. Don't forget that the numbers written as superscripts, that's at the top, are usually the mass numbers, while the numbers written below are the atomic numbers. So you can see that the atomic numbers remain the same, 1, 1, 1, 1. But the mass numbers change from 1 to 2 to 3. So let's take a quick example. Calculate the relative atomic mass of chlorine. When chlorine 35 has 75% abundance, while chlorine 37 has 25% abundance. Solution. We take the mass of chlorine 35 and multiply it by its percentage abundance, plus chlorine 37 and multiplied by its percentage abundance, 25. Everything divided by 100. This will give us 2625 plus 925 divided by 100. This will end up giving us 3550 divided by 100. And this will give us the relative atomic mass of chlorine to be 35.5. Please note that for some elements that have more than one isotopes, I'm referring to elements like hydrogen that has up to 3-4 isotopes or thereabout, you will multiply each isotope by its percentage and then add them all up and divide by 100. So, let's now take a look at relative molecular mass. The relative molecular mass of a molecule is the sum of the relative atomic masses of all the atoms in one molecule of that substance. It's also referred to as formula mass. Now, don't get confused that we were talking initially about relative atomic mass. Now we are talking about relative molecular mass. These are two different things. So, for a molecule, you might have more than one or two different types of atoms. We get their masses, add it up together, and get the relative molecular mass of that substance. A good example is when we take NaOH. You will see we have sodium, oxygen, and hydrogen all in that molecule. Sodium is 23, oxygen is 16, hydrogen is 1. If you add up all this, you will get 40 as the relative molecular mass of sodium hydroxide. Relative molecular mass of calcium chloride, CaCl2, is 40, which is the mass of calcium, plus 35.5 times 2, that is the mass of chlorine, is 35.5, and there are two of them. If you do this addition, you end up with 111. Note, the relative atomic masses of the atoms are usually given in all questions. Summary. In this class, we have learned of relative atomic mass, isotopes, and relative molecular mass, and of course, how to calculate them. Assessment. Number 1. What is relative atomic mass? Number 2. Calculate the relative molecular mass of H2SO4, where H is 1, sulfur is 32, and oxygen is 16. 3. Why are the relative atomic masses of elements not whole numbers? With this, we have come to the end of this class. Thanks for watching, and see you in the next class.